Hi friends, welcome to our channel. Today we will discuss the concept of pass-through hypothesis space. Okay, every concept, every concept that lies in between the least general one, and one of the most general one is also a possible hypothesis. What is the least general one and the most general one? So here general one means from the given literals. For example, length is equal to 3, back is equal to s, gills is equal to no, teeth is equal to some few. These are some of the literals. From the given literals, we are forming a conjective forms. From the given literals, we are constructing conjective forms. For example, length is equal to 3 and gills is equal to no and back is equal to s. So we are constructing some conjective forms. Based on these conjective forms, we are identifying the positives and negatives. Based on this one, we are identifying the positives and negatives. Here the least general one means restriction version, that is the restricted version of the letters. The most general one means it covers all the positives. So between this and those, we will consider an example later. Between the least general one and the most general one, if a concept is present between the least and most general one, that is also a possible hypothesis. It covers all the positives. This hypothesis covers all the positives, and remember, none of the negatives. Remember, it covers all the positives, none of the negatives. Suppose the same concept is mathematically speaking, okay, the set of all possible hypotheses, that agree on a data. Suppose I am giving some data. The set of all hypotheses that agree on the data is a convex set. So the set of all hypotheses that agree on a data is a convex set. What is the meaning of this one? Consider any two data members. In the set. If we can interpolate between any two data members, on the set, the concept is present in between the least general one. And the most general one. Observe the same definition. Always the concept that lies between the least and the most general ones. Okay. Suppose, consider an example. For example, a some length is equal to, for example, I am considering dolphin example contains 4 features, length with 3 values, length is equal to 3, 4, 5. Okay, back is equal to yes or no, gills is equal to yes or no, teeth is equal to many or few. This is the example. Suppose it contains 5 positives and 5 negatives. Assume it contains 5 positive statements and 5 negative statements. For example, A, length is equal to 3, gills is equal to no, and back is equal to yes, and teeth is equal to many. Assume, this is just an assumption. For example, this is the form, logical expression or conjective form. This expression covers only one positive example. For example, assumption, this covers only one positive example. Then what is our aim? We have to cover all 5 positive examples. Then what we will do? Suppose we are moving to the most general one. So generalization means step by step we are removing a literal. Suppose this is a literal. If we are removing a literal, means it covers more examples. If we are removing a literal, means it covers more example. If we are adding a literal, whenever we are adding a literal means we are providing the more conditions. That is a specialization. For example, step by step we are moving and finally true. That means this covers all the examples. It covers all the examples. For example, before this one, bake is equal to yes. It also covers all the positive examples. It also covers all the positive examples. But in this process, there is a problem of, suppose each and every step we have to provide specialization. Each and every step we have to make the specialization. That is, it does not cover any negative. Does not cover any negative. Okay. So the only single point is whenever we are removing a literal from this conjunctive form, it covers the positive. If we are adding a literal, means that is a specialization. If it is specialization means that is a concept for negatives. Okay. So a concept is here. A concept is complete and a concept is either consistent. So a concept is either a complete concept or a concept is a consistent concept. Concept is a complete means it covers all positive examples. Observe the line. It covers all positive examples. A concept is consistent means it does not cover any negatives. Now move to the first one. Complete means it covers all the positives and at the same time it may also cover negatives. The only point is it has to cover positives, even though whether it covers negative or not, that is not the question. So complete means if it covers all the positives, then the concept is a complete concept. If it does not cover any negatives, then only it is consistent. If a concept is both complete and consistent, that is called version space. So version space is both complete and consistent. That means it covers all the positives. So the starting of our topic, I am discussing one point. So the possible hypothesis covers all the positives and none of the negatives. So this one, version space is both complete and consistent. That means it covers all the positives and none of the negatives. For this, we are defining an algorithm. Okay. So the next one is the most general consistent hypothesis. The most general consistent hypothesis. Generally, identification of this most general consistent hypothesis is somewhat difficult than the least general complete one. So generally identification of consistent is somewhat difficult than identification of complete. This is the process of enumeration. So enumeration means step by step we are adding. Step by step we are adding the literal. Step by step we are removing the literal to make more specialization. That means to identify the most general consistent specialization. Identify the most general consistent specialization of a given concept that covers all the positives, and among those most general consistent specialization we have to find a minimal specialization. Okay, we have many number of most consistent generalizations. Among those we have to identify the minimal specialization that covers the positive. So no problem, we will discuss algorithm. Algorithm clearly explains the concept. What is the algorithm? Algorithm, most general consistent C comma N. So the purpose of the algorithm is to find out the most general consistent specialization. Remember, not generalization, specialization. Okay, So what is the input? The input is C comma N. C is the concept. C is the given concept. That is, for this given concept, we have to identify the most general consistent specialization. N is the set of negative examples. For example, in the question I discussed, we have 5 negative examples. So N is the 5 negative examples are stored in N. What is the output? Output is the set of concepts. Yes. Output is the set of concepts. Yes. So initially we are calling this algorithm by considering the C value is equal to true. So the concept value is equal to true. What is the meaning of C is equal to true? C is equal to true means it covers all the examples. That is the most general one. C is equal to true means it covers all the examples. By considering C is equal to true, we start the algorithm. Now write the algorithm. If C does not cover, suppose I am writing a concept. Suppose the concept length is equal to 3 and gills is equal to 4. Suppose if C does not cover any element from N, okay, here I am writing a concept. For example, the concept is A, length is equal to 3 and gills is equal to no and bake is equal to yes and teeth is equal to many. For example, if that concept C does not cover any element from N, that is, the concept covers the only positive element, then what we will do? So that is right, return C. If it does not cover any negative means that is our requirement. So simply return C. For example, so next one, S is equal to 5. Initially the no concept is placed in our result. S is our output. S does not contain any value. S does not contain any value. So next one is, for each, what is our aim? Among all these specializations, we have to find out the minimal specialization. We have to find out the minimal specialization. For each minimal specialization, C dash, assume the minimal specialization is C dash of C. Do. For example, the set of C is the set of concept. Suppose the concept C, for each minimal specialization C dash of D. So minimal specialization is a C dash, then simply SC is equal to S union NG consistent of C dash comma N. So recursively apply the procedure at each and every step. We have to identify the minimal specialization, that is added to S. So by the completion of this loop, we are finding the minimal specialization C dash, that is end of the loop, and finally return S. Okay, the return S. So observe, C is the concept. For this concept, N is the set of negative examples. So our answer is yes. S is the set of concepts. Among the most general specialization, we have to find the minimal specialization. How we are finding minimal specialization? Step by step, we are adding one letter. For the given set of letters, step by step I am adding one letter. Okay, see this one. S union. Step by step I am adding one letter until it is the minimal least specialization. So this one is called the most general consistent hypothesis. Now one more point is closed concept. Before this concept, I will explain one example. For example, A is equal to length is equal to 3. Suppose the example, length is equal to 3, gills is equal to no, bake is equal to yes, teeth is equal to many. For example, length is equal to 3, gills is equal to no, back is equal to x. So suppose the teeth is equal to few. Suppose write any example. For example, this one. Now move to B. Suppose removing any specialization, it has to cover one more positives. So step by step we have to cover positives, remove these letters. Suppose the example, suppose in this one I am making as length is equal to 3, 5. So we have two possible length. Length is equal to 3, 5. Same gills is equal to no, back is equal to s, teeth is equal to few. This is the specialization. Sorry, generalization. Generalization. Suppose next I am adding one more thing. See, length is equal to 3, 5. Gills is equal to no, and back is equal to yes, to cover remaining positives. So I am step by step modify this equation, that is modify this conjunction to satisfy, that is to accept all the positives, to accept all the positives. Suppose D, length is equal to 3, 5. D, length is equal to, okay, suppose gills is equal to no and back is equal to yes. That is to cover all the positives. So for example, it covers only one positive. Suppose it covers two positives, it covers some three positives. So to cover remaining positives, I am writing, that is there is no restriction on length, no restriction on teeth, and E is equal to back is equal to S. Suppose F is equal to true. Consider this example. Suppose consider this example. Suppose gills is equal to no. If you refer the example in the textbook, you know the textbook. If you refer this example, gills is equal to no, back is equal to yes. Cover all 5 positives. Cover all the 5 positive examples. Suppose observe E. In E, I am removing this letter. Gills is equal to no. Only back is equal to yes. This also covers all the 5 positives. That means if you are drawing a coverage curve, for example, D comma E, this position, D comma E points on the same position. D comma E points on the same position. If then D comma E is the closed concept, that is E is the closed concept, that is a concept internally applies the condition. Suppose even though if you know back is equal to yes, it has an internal condition as gills is equal to no. As gills is equal to no, then it is a closed concept. So a concept internally includes all the conditions. That is a closed concept. This is the concepts of path through hypothesis space. So what we will discuss? Simply first the definition. Every concept that lies between the least general one and the most general one is a hypothesis space. So the first one. Next definition is the convex set. In terms of convex set, we can interpolate between the two data members. If you find the interpolation between two data members, that is a concept is also present between the least general one and the most general one. In all the two cases, it covers only positives and none of the negatives. And the second point, version space. A concept is complete, means it covers all positive examples, even though it may covers negative examples. A concept is consistent, means if it does not cover any negatives. A concept is both complete and consistent. It is called version space. Next we are defining an algorithm. The algorithm is finding the most general consistent specializations. In this one we are finding the minimal. Among these most general, we are finding the minimal specialization. So algorithm. The algorithm is called by calling C is equal to true. Here C is the concept, N is the negative examples. What we will do? Suppose if C is not covered any negative, suppose a concept C does not cover any negative, then simply written C. That is, our answer is C. For example, that means if C covers, then we are moving to for loop. For each minimal C dash, suppose C contains some set of letters, for example this one, for each literal C dash, each minimal literal C dash, if it is a minimal, perform union with yes, finally written yes. And the last one is a closed concept. Closed concept means step by step we are moving to the most general one. That means this covers all the examples. Suppose the break is equal to yes, it covers all the positives. This also covers all the positives. If you draw a coverage curve, the 2 points on the same curve, the 2 points on the curve at the same position, that means these are the closed concept. That is, a concept internally builds the conditions for identification of positives. Okay. In the next topic, we will move to the beyond conjective concepts. Thank you.